Welcome back to the garage. Last video, we got the engine fired up. Sweet, sweet horsepower. Hope you enjoyed that one. I know me and Dad sure did. Hearing that thing run, it's glorious. As you saw in that video, I got a few things to work on, so check out what we got going today. So first thing I'm gonna be messing with today is these two fittings under here. Really, I think it's just this one that's leaking right now. This is the transmission cooler. It's leaking just a little bit, so I'm gonna pull that fitting off and see what's going on. I think it's leaking from, there's a straight thread O-ring that goes into the housing of the transcooler. I think it's leaking at the O-ring. I noticed it was pinched pretty bad. That got tightened, jacked down too tight, and the O-ring was pinched. So the O-ring might be cut. I'm gonna take that off and just inspect it, and that's what we'll be starting with today. The back one was leaking even worse for the same reason. I loosened that one and snugged it back up so the O-ring wasn't pinched like it was, and that one seems to be fine. So I'll be messing with this and seeing if I can figure out what that is. Can't get much of a camera angle in here, but that would be why it's leaking. I couldn't see that from the other side, especially without light under here. But now with light, and I'm looking at it from the other side, I can take that off and take care of it. I don't know how good you'll be able to see this, but we'll see later. I can barely get in here myself, let alone get you in here with a camera. This all the way off and take a look at the O-ring and see if it's smoked or not. Surprisingly, the O-ring looks okay. And I don't like how sharp that edge is. It's basically like the powder, where the powder coat met the, the part of the housing, whatever this is. It's like really sharp, and that's right where the O-ring engages. Let me try this little thread file. Here's where you need 3 hands. Try and tighten this. Tighten the AN fitting, keep the O-ring fitting from getting too tight, and keep this from screwing up the clocking that I want. Got a few more things taken care of. I replaced the temporary oil pressure gauge sending unit that we were using just for first startup with the sensor that I'm going to run. This is the one that hooks up to my CAN bus and will show the oil pressure on the dash. Also properly hooked up the ground wire for the Hobbs meter right there and put in a wire loom because that was just strung across the interior of the buggy for the startup. All right, got a few more things cleaned up. Got the O2 sensor wired. So it starts over there, comes up through here, underneath that. And then I have a bunch of extra slack to get rid of, so I'm gonna zip tie it there, and that'll be under the seat. Then it comes across and gets power over here. I'm gonna fish this wire in through here a little bit later, but I'm waiting to do that because I ordered some more split loom. I'm out of split loom. So I'll loom this wire out for going up through there and plugging in here, and that'll be under the panel. I also started tightening these. These are tight now. Got the shifter more tightened. I don't know if I'm gonna have to come off of that or not for any last minute routing. Because of that, I left these ones off for now too. But I also got the rear steer control wired and also screwed in, so that's pretty sweet. So I'm obviously going to tighten that later, and then once I get the panels on, I'll figure out where the best, cleanest way for this to sneak in between the seat and then zip tie in there somewhere. Sorry, zip tie in there somewhere. So the way this will work, this little switch on top is a joystick. So you have left and right for the rear steer. And then it's self-centering, so it will come back to center automatically when you let go, unless you pull this momentary switch, which temporarily disables the rear steer. So you can hold it in a position, and then when you let go, it'll rear steer. I also have a switch disable right here too, so I can flip that and then disable the rear steer if I want to leave it disabled for an extended period. Editor here. I just wanted to clarify what I meant by disabling the rear steer. So I have two switches actually, and one is the ability to disable the rear steer entirely, but the other switch, the one that I was just showing, was for disabling just the self-centering feature of the rear steer. So that's pretty cool. So I can, steer the rear steer in either direction, let go, and it will self-center, or I can flip that switch and then it will stay disabled as far as the self-centering is concerned. So I have both those options, and then once I get this thing running, I can show you that later. Other than that, I was just underneath, taking a look at all the wires under here and making sure that it looks fine, zip tying a few things under there. So I got the split loom in. I was able to clean up the wires a little bit more, so now that lead that was for the switch panel to get power from the fuse box is loomed out and tucked in, so you don't see that anymore. It's basically that wire right there. So I put the split loom on that. Also, you may have noticed here there's a couple of basically flying leads on this switch harness. This is just a little wiring harness that I made to be like a quick disconnect from the relays to the switches. So these are all the trigger inputs for the relays. The Deutsch connector that I'm using happened to have a couple of extra pins that I didn't have switches for and didn't actually need to use. So I figured, since I was making this harness, with this, heat shrink connectors and everything else, and the loom, I figured I'll wire it with the two wires, even though I don't need the switches, just in case sometime down the road I actually want to add two more switches for something. They're not connected to anything, but so they wouldn't do any damage or any harm just leaving them like that. But I decided to just kind of, put some electrical tape on the end and zip tie it kind of in here nice. So once that gets all tucked in there, that'll be a little bit cleaner too. There's also another wire that I ran for, I'm gonna clean this up too, another wire that I ran for the gas gauge. So now the gas gauge sensor has power and ground. I haven't finished this off yet because I need to run a cable for the rear steer, which is down here. And there's likely going to be some additional wires going in for the rock lights. And I haven't zip tied it and cleaned all this up because I'm probably going to bundle all that together. The rock lights I'm going to be working on today. I'll show you that. So this is an example of one of the rock lights. I can't remember how many came. I found a rock light kit on Amazon, and these are waterproof potted LEDs, single color LEDs. I wanted to get one that I didn't need an app to run because I have my own wiring and switches and stuff. So it came with, this is one of the lights, and it came with its own harness. The mounting options for this involve screws and something else, but it also came with these little rubber mounts. And I didn't know exactly, you know, before we did the powder coat, I didn't know exactly where rock lights were going to end up going. I kind of just kicked that can down the road until later. My original plan was I'd like to use magnetic mounts. So that's what I got going on here. I just ordered these little magnets, these little neodymium magnets on Amazon. They make these in different sizes, but these are super strong. And I just got these countersunk M3s that will fit in the holes, and it'll get screwed down from the top down like that. But these are quite strong. I mean, I don't even have these screwed down, but I mean, that takes pretty significant force. Even through the powder coat, it sticks on the buggy pretty good. So I think these are gonna work. So I'll start laying out where I want rock lights to go, and then figure out where the wiring is gonna have to go for all that. So that's what I'm working on today. This is the rest of the wiring that came with it. It's got these flying leads with these connectors, so it's kind of modular in that you can plug in as many as you need and then not any more than that. So this is like a breakout. You can see it's like a breakout for all these little modules. It's even got like more modular wiring. And this kit came with, oh, here's an example, not in the rubber. You can see, actually you can't quite tell from the camera, but there's clear, I'm trying to give you an angle. These are potted, so these are all waterproof. There's like clear potting compound that covers that whole wiring situation up, so that's pretty cool. Now this came with, you know, everything you would need to hook it up. You know, it's got a toggle switch, even an LED toggle switch, and also, you know, fuse, relay, everything. Obviously, I don't need all this. I already planned ahead and have provisions in the fuse box for one circuit for this. So I'll have to take a close look at how this all connects to the switch and figure out what the cleanest way is to bypass their switching and just run it into my setup. Probably end up taking some of these connectors off and then just re-terminating them with what I need. So this is the rubber base that they come with for mounting to tube. See, it's got a curvature in it. Camera screen adjustment. So that goes on there like that. It's meant to actually screw down with these socket head screws that it came with, but I don't want to put more holes in the buggy, so I'm using magnets. So it's kind of like a reverse mount that I'm doing. I'm getting these custom length M3 countersunk screws. Which is the only size I can use to go into that. See, the screw has come in from the bottom. Got the countersunk. So, oops. Of course, magnets, they stick to everything. Especially when your table is metal. This will end up mounting the other way. You know, it has to mount that way, basically, instead of the other way, top down. Doesn't really matter much other than aesthetics, but these aren't really, you're not going to see them much. They're going to be tucked into an area. Now the holes are way bigger. Whatever it's like a 1/4 inch in the screws that came with it, whatever the metric equivalent of 1/4 is. So I need to kind of do this washer stack up situation to get this to fit. A little bit less than ideal, but it's not like it's clamping down into rubber, so it's not like it's gotta be super tight or anything. no idea how good this is coming out on the camera. It's hard to watch the camera and do stuff at the same time, especially this fiddly little stuff. If you're not familiar with rock lights, these are for off-roading, the off-roading community. These are basically used as undercarriage lights to shine in the wheel wells and on the underside of the vehicle. And as their name suggests, they're for rock crawling. So you can see at night, so you can see the rocks that you're crawling over. So you can put your tires where they need to go. They also come in handy for when you have to work on your rig. It conveniently lights the whole underside of the vehicle, so they're good for that too. Need more like that, and I'll get started on the fuses. Comment if you know what movie that's from. All right, so I'm doing the wiring for this rock lights kit, and it comes all ready to go as far as using their wiring. It comes with this LED switch, this relay. You know, you plug this relay into here, and then they're meant to, and all you have to do is tie, you know, fused power and ground here, these two connectors. Now that's all well and good, but I already have a relay, a switch, and a fuse in my fuse box, and I don't want to use this switch. I want to use all my stuff. So I figured I'd show you how you can sort of, not really reverse engineer, but kind of just figure out what's going on with this wiring so you can bypass it. Because essentially what I want to do is, you know, they have this special proprietary connector here that takes their LED switch that controls it, and then ultimately just drives this relay. So if I could just, you know, since I already have a relay, I basically just need to act as the switching side of the relay. Now, on a typical relay like this, power comes in on generally on pin 30 here, and then this is pin 87 that switches the load power out to the actual load. That's what turns the LEDs on. And then this is pins 85 and 86. This is the switching side of the relay. So this is like where your switch activates the coil in the relay. Now, depending on the relay, you know, these can be wired with a resistor or a diode. And if it's a diode, then the power and ground matters here. But if it's a resistor, it doesn't. So sometimes, you know, you can have one be the power, one be the ground. But I'll show you how you can figure that out. So I have my multimeter in continuity mode. So it will beep when there's continuity. So we can sanity check ourselves before I take this apart. I'm going to cut this heat shrink off and depin these connectors, but we can sanity check. So if we connect their power wire, we should have continuity on pin 30 here and nothing else. So that's verified. Ground should be one of these two. Like I said, sometimes it's one or the other, so you can just test it. So 85, nothing. So they're pulling 86 to ground, and there should be nothing on the other two. And just as a final check, since this is ground, then this should be power from the switch. So we should have continuity on power and this pin when the switch is on. Right now it's off, so we have nothing. When the switch is on, we do have continuity. So if I take my connector that I'm gonna pin into this is the switched power and load power and ground. So power to this pin and ground to this pin, and you're done. So that's how you can kind of figure out what's going on with, you know, stuff like this. All right, with the heat shrink cutoff, we can verify what we already verified with the multimeter. So that kind of shows that you can do this without even being able to see this if you have like a more complicated wiring harness or something. But with this cut off, we can see their fused power comes in on 30, on pin 30 there. And then there's another red wire also pinned into that, which that goes into here, which if you follow this just goes out to their switch. So that's power for the switch, because this is an LED switch, so it uses power also. So that's power to run the switch. The yellow, as we can see, let's reorient ourselves here. The yellow is the other side of the switch. So when you switch the switch on, power goes through the relay from here and into ground, charging the coil, which switches the load between 30 and 87, which is, you can see that red wire and that ground goes into the rest of the harness to actually power all the loads. So that's what I was able to verify with the multimeter, that that's switched power and that's switched ground, which is all I need. So essentially I can depin, I'm going to depin all of them so I can keep this in case I need to use this relay for something else, this relay holder, but I'll depin those two to use, and then that's what we'll wire into my wiring. I'll use my depinning tool, that's what this does. Sorry, this is kind of awkward. I'm trying to do this behind the camera. There you go. Those are the two that I'll need. Those are the two that I'll use, rather. There you go. So these are the two that I'll use. Now, the ground is in parallel with all this other stuff that needs to be grounded, the switch, the relay. So probably the easiest thing to do is just to cut off these spade connectors and I'll repin the wiring into one of my connectors. All right, so there you go. That's the finished product. This plugs back into this big harness to break out to each of the individual lights, but that's how it'll terminate into my wiring. Nice clean Deutsch connector. Like I said, I already have the circuit relayed and fused to my own switch panel. So that's with heat shrinks on and all ready to go. So I have a few of these rock lights installed in a few spots where I want to have them. So now the fun task of more wires. There's 9 million miles of this. I gotta get things routed where they need to go to the individual lights, and then also plugged into my power. Thankfully, my hookup is nice and clean. It's just this one end. The switches are already integrated, so that'll plug in right there. Before I plug that in, I'll start figuring out where the tails of this are gonna go. All right, before we get ahead of ourselves, trying to route all these wires nice, let's turn it on and see if it works first. Rock lights is there, so we should see light. Hey, we have light. Obviously the shop lights are on, so you're not gonna be able to tell that much. That'll probably be something like that. Pretty cool. You could use another one up front, maybe. Run another one on the other side of the winch, maybe. Thought about doing one up here shining into the engine compartment, but that's going to be in your eyes when you're driving, so. Update on the rock lights. So I got this rat's nest all sorted out. I just got these bundled together in separate little coils of zip tie. The breakout part is right there, and then that'll feed up into here. And then it just continues on in that direction. And then there's a few that go to the back here. I haven't totally, this isn't totally cleaned up yet. I'm waiting to, finalize how this is all gonna bundle together until I get the seat in here, because I don't know what's gonna be best for like how this is gonna route this way. And I'm trying to avoid, zip tying this all together only to have to cut the zip ties and then reroute. So wait till I get the seat in here. But that should be, these stay pretty tight. I can have this basically come up like this underneath the seat. The seat all sits up here, bracketed here. So there should be no issue with all that sneaking under the seat. This is the driver's side panel. I just put this in here to figure out where it's gonna sit. So I'll probably, zip tie this to, to this part of the seat bracket or something. I put heat shield tape on the underside of this panel as well, which I should have done on the passenger side panel before I put that in there, but I forgot about it. So I'll have to I'll put some heat shield over there as well later, but that'll be more of a pain because I'll have to do that after the fact. And I don't want to blow all that out of there, obviously. Also, we tested the radio and intercom, and I had to make a modification to where the headsets plug in here. This is protruding more than I would like. Can't really avoid it because of the shape of the connector. The way the connector is designed, it's got a sleeve for weatherproofing. So these connector receptacles have to be proud of the mount surface so the sleeves can slide around them. I didn't test the radio yet because I don't have the antenna plugged in. You don't never want to use a radio without the antenna plugged in. But the intercom seems to work, the headsets seem to work, so that's pretty cool. Last thing for today, got the backup camera wired. Thick. All right, I think that'll do it for this one. Finally getting to the end of the tedium of wiring. Getting the rock lights in is kind of the last major wiring project that I had on this thing. I still have to run a antenna cable for the radio. I think what I'm gonna work on next is just the final zip tying kind of wiring situation buttoned up as far as it looking as nice as it can, especially in that center console area where there's kind of a mess. There's a lot going on in there. I'm gonna try and tidy that up as best as I can. And then after I get that tidied up, I think the next logical step will be starting to get the floor pans in and the seats in. I have a little bit to do on the skid plates, and I also have to run the brakes. So that's the last thing, I think. Seems like there's a lot of last things. I gotta do the skid plates, run the brake lines, hook up the rear steer. That's pretty easy. I gotta get a couple of hydraulic hoses made. But after that, it's gonna be driving. See you then.